Once again, the SAT is testing our ability to identify what the y-intercept means in real life. Remember, it's always like our starting point. If it was a plumber, it's what they cost before they even do an hour's worth of work. If it's a race, it's how far they were before the clock even started for the race to begin. In this case, they're asking us, they give us the speed of sound is a linear function of the air temperature. It's given by blah, blah, blah. S of t equals 0.6t. And we can see that this is the SAT again throwing some bones at us here. Or I don't know, bones means it's a good thing. So throwing some wrenches at us because instead of just saying y equals 0.6x plus, 331.4, which is your standard slope intercept equation, they put in these other letters to make it a little bit more complex. Which of the following statements is the best interpretation of 331.4? Well, if we know that really we can just rewrite this as what I have here in the graph. And again, this is the no calculator section. Can you use the graph? No. Do I want you to? No. I just want you to understand where I'm coming from when I see that when the when we think about what this is, well, let's think about setting this to 0. We set x to 0. What we realize is that the output is 331.4. Right? That's what this situation is and this dot right here. And what that means is that it's the starting point. So that's why in this case, the situation is A. Oh, well, I meant to say it's A. The speed of sound in meters per second at 0.6. It's not the speed of sound in seconds at 0.06 because that means that you would be multiplying 0.6 by 0.6 to get, and that's not going to give you 331.4. The increase in the speed of sound per second that corresponds with an increase. So what that means is that you were thinking that it's a rate, and it's not because it's not being multiplied by anything. So it can't be a rate, which also eliminates D.